Okay, so if we have a function of two variables and it's differentiable, then f has a directional derivative in the direction of any unit vector, and that directional derivative is the partial derivative with respect to x multiplied by a, and the partial derivative with respect to y multiplied by b. Okay, so why don't we go ahead and just calculate one of these. Okay. So let's start off with f of xy is going to equal e to the x and sine of y, and let's do it at a point at 0, pi over 3. Okay? Let's find it in direction of the vector -6, 8. Okay? So the first thing we need to do is we need to find the partial derivatives and evaluate the partial derivatives at that point. Okay? So f sub x of xy, well, if I take the derivative with respect to x, I'm just taking the derivative of e to the x, and the derivative of e to the x is just e to the x. So that's going to be e to the x times sine of y. All right? And now let's evaluate that derivative at the point 0, pi over 3. Well, e to the 0 is just 1, and sine of pi over 3 is going to be the square root of 3 divided by 2. All right, now f sub y of xy. Okay, now I'm ignoring the e to the x because that's a function of x, but I'm taking the derivative of sine of y because it has a y. So that would become e to the x, now cosine of y. So f sub y, well, e to the 0, well, all right, 0 pi over 3. Okay. E to the 0 is just 1, and cosine of pi over 3 is 1 divided by 2. Okay. So we have f sub x and f sub y at that point. Okay. Now we have to consider that we want it in the direction of -6, 8. Okay. All right, we want it in the direction of -6, 8. But if we look at our definition, it says, okay, if f of x is differentiable, we have a directional derivative in the direction of any unit vector u which equals ab. So what we have to do is we have a vector in a direction, but we have to turn it into a unit vector. Okay? So, what is u going to equal? Well, u is going to equal, okay, so we still have this point, -6, 8. Okay. Now divided by its magnitude, which would be the square root of -6, now squared, plus 8 squared. Okay, so -6, 8. Okay, so that's going to be the square root of 36, now plus 64, which is -6, 8. That's going to be square root of 100. Okay? So our unit vector is going to be -6, 8 divided by 10. All right? So now let's figure out what our directional derivative is at that point. So So we have negative 6 over 10 and 8 over 10. And then we have our partial derivatives right here. Okay? So this means that our directional derivative at that point in the direction of negative 6, 8. So du of, okay, I'll write this as 0 comma pi, or f of 0 comma pi over 3. It's a little messy, but I think I'll get the point. All right, what is this going to equal? This is going to equal, okay, so our first in the partial derivative was going to be root 3 divided by 2, and then we're going to multiply that by negative 6 divided by 10. Right? And then our next one is going to be plus 1 divided by 2, and then multiplied by 8 divided by 10. I'm aware that that can be simplified, but I want to leave that 10 on bottom. Okay, so that way we can write this thing as negative 3 times the square root of 3 plus 4, all of that divided by 10. So that's the directional derivative. And what is this? What is this quantity that we're describing right here? We have a surface, okay? And we're considering this surface, and we have another vector that's sticking out, that is in relation to this surface, and we're trying to find the slope of the tangent line at a point in the direction of a vector. Because you have to imagine, if you have a surface, you can have vectors pointing in any direction, okay, at a single point. So if we want to calculate the slope of the tangent line at that point in a certain direction, then this is what the directional derivative actually does, okay? We're going to have another definition, because there's another thing that is very important when talking about this, okay? That is actually a component of this, okay? That's the gradient vector. Right? So the gradient vector, you'll see this symbol a lot coming up. The gradient vector is going to equal, well, partial derivative with respect to x, f sub y of xy, like that, okay? Another way to write this is the partial derivative of x times I plus the partial derivative of f with respect to y times j. Okay? If you want to write this in 3 dimensions, well, then the gradient vector of f of x, y, z, this is going to equal f sub x, f sub y, f sub z. And so that would be the partial derivative of f with respect to x times I, plus the partial derivative with respect to y times j, and the partial derivative of f with respect to z times k. Oh, we'll go off the screen. Okay. And now, what is the gradient vector? Okay? The gradient vector is actually the direction of steepest ascent. Okay? And another thing to point out is that the directional derivative d sub u of f of x, y actually equals Well, it's the gradient of the f of xy dotted with u. Okay? And so we'll be using this type of vector quite a bit.